Okay, we'll finish lecture 1 by looking at sources of information, some of which are a bit more reliable than others, McCann's and Widdowson being the core data for a lot of what we use, even though you may not access the actual McCann's and Widow data that often yourselves. And then think about reporting your results and comparing them with what other people have found previously. Okay, so MyFitnessPal, widely used. A little bit of search for cheddar cheese. When you come up with cheddar cheese, it comes up with a number of different measures, ounces, whatever an ounce is. An ounce is 28 grams. A quarter of a cup, I have no idea what that is. 19 grams, that's a peculiar one. One slice, how big is a slice? And the perhaps more useful 100 grams. So MyFitnessPal being a little bit obscure there, but then if you look at some of the data, it's actually a bit rubbish. So look for cheddar cheese, 2 different sources. There's one on the left, it's probably reasonable. If you look at on the right, apparently cheddar cheese contains 0 calories. A result confirmed by 11 users, most recently in April this year. Obviously this is nonsense. It would be very nice if cheddar cheese contains 0 calories, but unfortunately it doesn't. So there are better sources. MyFitnessPal is probably okay if you are scanning the information from a barcode from a commercial pack. If you were looking at the information which somebody else has put in, it's probably, in many cases, quite dubious. You do need to check. More reliable sources we've used Jenny Ridgewell. There's also Nutritics as well, which will be introduced to in the future. They're based on information which originally was described by these 2 people, Elsie McCance and Elsie Widdowson and Robert McCance, pioneer and nutritionists, 2 of the most famous people in British nutritional scientists. Elsie was a postgraduate student of dietetics at King's when she met McCance, a clinical scientist and head of the hospital's biochemistry lab. They worked together for 60 years and were responsible for many developments in our understanding of nutrition. They also co-authored a very famous set of books, of which more in a moment. They were experimental scientists. They did some experiments during the war. Along with Jack Drummond, they were 2 of the main people responsible for the British wartime diet, which is often regarded as one of the best diets for the population in history. And they did experiments on themselves. So this set of experiments, they were in the Lake District in December, and they had for breakfast. So I'll pop up a example of a breakfast there. So for breakfast they had porridge, they had some bread, they had some autolyzed yeast. That's basically sort of Marmite type stuff. And then went on an 80-mile cycle ride in the 28th of December 1939 in the Lake District, which was probably quite brisk and chilly then. They did a lot of experiments on themselves, which ethically these days, of course, we wouldn't be allowed to do. And there's Elsie injecting herself with solutions of magnesium, calcium and iron, and then probably running up Scarfell or something to see what the effect was. Ethically not on these days. This is their famous book, famous collection of books which you have access to. You can get access to it via the library, and also show another link you can get to it directly, which is basically the mother lode of information on food. As I mentioned a few times, food is heterogeneous, and different foods from different places will have different values, but this is a good basic source if you want to do some comparisons, and we'll talk about that a little bit later on. So the nutritional program at Jenny Ridgewell, for example, is based on this. It's probably got a wider range of things in, but this is the core. McCance and Widdowson provides the core data. The ebooks available from various sources, including this one for the Royal Society of Chemistry, which I'm not going to link into, but you can do it yourself. And also you can get it directly from the library. It's a series of PDFs which you can access online and you can download. Yeah, so there's just some examples of them: cereal and cereal products, milk and milk products, and egg dishes. When you drill into them, you get the macronutrient information. So we got water and total nitrogen, which links more or less directly to protein, fat content, carbohydrates, and energy values. So the macro values there. You can also drill down further, you'll find more information on micronutrients. So here's a little task for you. Search McCance and Widdowson for example, green or red peppers. Make sure you can find the macronutrients, the minerals, and the vitamins. They won't be together because the macronutrients for all the things that come in the various categories come in one set of tables, then the micronutrients. So you'll have to do a little bit of searching. Okay, just to wrap up, data and comparisons with analytical results. Just one slide to finish off. You're going to get some results in the lab, maybe your project, report them. Compare them to standard sources such as McCants and Widdowson or good reliable databases, and compare them with literature results from other published studies. But as I mentioned many times, bear in mind food is heterogeneous. Different methods both for extraction and analysis may give different results, but you should always compare your results to what other people have got, and don't worry if your results are different. So there's an example quoted from a student paper this year. They've done an analysis of crab meat, and this is taken from a paper on crab meat. Yeah, and think about how you can improve things. So again, talking about crabs, the age of the crabs might be a factor. The gender is a factor. We know this. The anatomy is a factor, where you take the sample from. The size of the factor, which may or may not be related to age directly. Geography, where the crab was sourced from, how it was stored, what extraction method you did, what analytical method you used. All of these will affect your results and need to be taken in consideration when you present your results. And again, don't worry if your results are different from other people's. But the thing you should always do is the second set of information there with the arrow. Think about how you can improve your experiment. And a larger sample size is always the best way to improve things normally. It might be able to do a different extraction, maybe a different analysis. When you write up your methods, in your critical analysis, consider these issues. Do some reading around different extraction methods, different analytical methods. That's okay. That finally completes this lecture. Thanks for listening.